Suppose you need to find inverse Z transform of say 7Z minus Z power 3 of Z plus 1 and Z minus 1 power 2. Okay, then in this case, how we will do? Again, as usual, we take the factor Z outside from here, because when we can write 7Z minus Z power 3 as Z outside 7 minus Z square. So for partial fraction, we consider this term Z plus 1, Z minus 1 power 2. So using the same idea of partial fraction, for one linear term, A over Z plus 1, this linear term repeated twice, so we get two terms, Z minus 1, C over Z minus 1 square. Then we will take the LCM, which will be same as the question. The question is Z plus 1, Z minus 1 square, 7 minus Z square. So it will be Z plus 1, Z minus 1 power 2. We are looking for term with A. With A, if we divide Z plus 1 with this term, we get Z minus 1 square. B, if we divide Z minus 1 with this, we left with Z plus 1, Z minus 1 plus C, we get Z plus 1. It is same as how we have done it for inverse Laplace transform. So comparing the numerators, it will give you 7 minus Z square is equal to A times Z minus 1 square, B times Z plus 1, Z minus 1 and C times Z plus 1. So here, as we have three constants A, B and C, we need to substitute three different values of Z that we get from here. So from here, Z plus 1 equal to 0 gives you Z is equal to minus 1. So we use it here. 7 minus of minus 1 square. So this is equal to A times minus 1 square, and then when we put Z minus 1, Z plus 1 here, it will become 0 and 0. So B with 0, C with 0. So I am just writing it quickly. So 7 minus 1 gives you 6, minus minus gives you minus 2, minus 2 power 2 gives you 4, A. So this gives you A is equal to 6 by 4, which is 3 over 2. Second value of Z from here, Z minus 1 equal to 0 gives you Z is equal to 1. When you use it here, 7 minus 1 is equal to, factor of A becomes 0, B becomes 0 and you left with C. So it is like 6 is equal to 2C. C is equal to 6 over 2, which is 3. Now to get last constant B, we don't have left with any other value here. So use any value of your choice. I will go for 0 because it's easy to replace. So 7 equal to, again using this thing, A times minus 1 square gives you 1 plus B times 1 minus 1 and C times 1 because Z is 0. So 7 equal, A is from here 3 over 2, minus plus become minus, B plus C is 3. So this gives me B is equal to 3 by 2 plus 3 minus 7, that is 3 by 2 minus 4. When you solve it, it's 2, 3 minus 4 times 2. So 3 minus 6 over 2. This gives us B is equal to minus 3 over 2. So this is what I told you, like to check the value of A and B is same, just differ in the sign. So on substituting the values of A, B and C, here we get this term. Now multiply both sides by Z. So we get 7 minus. So what we did when we multiplied with Z, here we get the original question. Here we got z over z plus 1, z over z minus 1, z over z minus 1 square. Then applying inverse z transform on both sides. So what we get? Inverse z transform of the left side, which is nothing but our quotient, 7z over z cube minus z cube, z plus 1, z minus 1 power 2 equal 3 by 2 inverse z transform of z over z plus 1 minus 3 by 2 inverse z transform of z over z minus 1 plus 3 times inverse z transform of z over z minus 1 power 2. So this gives you 3 over 2 for first one, minus 1 power k, minus 3 over 2, 1 power k or 1, both are same, plus 3k. This completes the solution.